Come, all you moonshiners, if you want to hear about the kind of booze that they serve around here.
Welcome to Barley and Hops. I'm George. We're always glad to have you back. Hobbyists, distillers, oh gosh, the whole community. We are here to help you unlock the mysteries of home distilling. Yeah. Now, today's video is going to be on a topic that we discuss on a regular basis. And I'm going to give you 3 guesses on what it is. And the first 2 don't count. Yeah, simple. We're going to do a sugar wash. Now, the sugar wash is the most basic. Some people call it an introductory level, but I'm here to tell you that I do a sugar wash on a routine basis because it gives me a product in which I can do a lot of other things with. If you follow me. See, we're going to wind up with a neutral spirit. And that neutral spirit, man, I can make a gin out of that. I can make a vodka out of that. I can condition that and make a bourbon out of that. I can make a Tennessee whiskey. You can do almost anything with a sugar wash. And oh, by the way, it's probably the most, I don't want to call it idiot-proof, but it's probably the most direct method of making a real quick wash. Because usually we call sugar a wash. And if you're using grains, we call it a mash. Because remember, a mash is a noun and a verb. So, forget it. So we're going to make a sugar wash. Here's the recipe. I got to throw this out just real quick. It's 2 pounds of sugar per gallon. Give or take. And it all depends on what your goals are. Remember that you have your own goals in what your gravity points are going to be. Mine, I look for about 1.090. That's just me. I find that the perfect level in which I can really get a good product because they say, well, George, if 2 pounds per gallon, why don't you use 4 pounds per gallon? Double the alcohol content. Why? Sure, why not? Guess what? We're not making spirits anymore, folks. You're making fuel. Okay? So once you get up to like 20% and you're looking for those really, really high alcohol by volume percentages, your entire wash is going to change and your yeast are not going to do exactly what it was you intended them to do. Simple as that. Okay? So again, quality versus quantity. If you're looking for a whole bunch and you're trying to make lawnmower fuel, yeah, shoot, go up to 20%, 22% if you can get there. But if you're trying to make a spirit that you can manipulate, you can work with, keep it down there around 13, 14, 11, 12, somewhere in that neighborhood. It's that much easier to work with. Okay. Now, there's a bunch of different ways to do this, okay? Right up front. You know, I've said this 1,000 times, that there's 1,000 ways to go about this, but as long as you don't violate the process, your technique is totally up to you. So what we're going to do is we're going to introduce sugar into warm water. Now, why do we do that? Okay, we all know that table sugar, if you take look, if you're making an iced tea, and you got some really cold iced tea with some ice in it, and you take a couple spoons of sugar and put it in there and stir it up, what happens? All those sugar granules sink to the bottom and you can see them. They just sit there for quite a while. It takes a while for them. I mean, they may not ever liquefy because it's cold. Well, you put them in warm water and it liquefies. Now, it's not, corn sugar will almost liquefy immediately. It's not crystallized. So, but if we're using table sugar, which is absolutely acceptable, table sugar is made up of glucose, fructose, and glucose. Yeast eat glucose first, yeah. And the other 2 are combinations of different molecules that make them up, so they just got to work a little harder to get at them. Well, let's not get it. We're not going to get into that. But the point is that we're just going to use some regular sugar. Now, I've got 2 10-pound bags and I got a 4-pound bag. I got 22-liter containers right here. And I got a little bit of water in each one of them. And I'll tell you why that's there. So oh, 5 gallons is 18.9 liters, somewhere in that neighborhood, but I got 22 liters capability here. So I'll make a little over 5 gallons, about 5.5 gallons. So I'm putting a little over 2 pounds per gallon in here because I'm going to put 12.5 in each one. But what I'm looking for at the very end is I'll float my hydrometer and make sure I get the right, and I'll show you that. Now, you'll see I've also got cold water in here in both of these. I got equal amounts of cold water in both of them. And the reason for that is that after and again, you can do this any way you want, but I've heated this water up pretty warm in both of them. Oh, probably about, I don't know, probably 110 degrees or so, or maybe even a little bit more. And that's so that I can liquefy all of my sugar in one clean swoop. So I'll pour my 12.5 pounds in this one and in this one. Make sure it gets all mixed up, and then I'll transfer this into here and this into here. And the cold water is in there so that initially it'll knock down that temperature. You see where I'm going? Yeah, I want to control temperature at the same time. Now, what are your options? Oh my goodness, your options are just make it like this and then let it sit overnight and cool down. That's just the long way of going about it. Okay, yeah. You can make it like this, and you can pour it in your bucket, and then you can put ice bottles in there, you know, or there's a bunch of different ways. The point is that you just want to make sure that you get your sugar wash to the proper temperature so that you can add yeast. I don't want to wait all night. So let me add this sugar, and we'll move on to the next step in what we're about to do. Now we're just going to add this 10 pounds of sugar in here slowly, at least a little slowly, and stir it. Now you stir it, like 3 times to the left, and then 3 times to the right, and then 3. No, I just said that because, that's the reason why this channel started, because, look, I don't care how you stir it, as long as you mix it up, okay? I don't care if you use a whisk or a paddle, but when I first started research, this is years ago, I heard so many different versions of how to do something, and everybody claimed that, that's the only way you can do it. The only way. Oh, yeah. Yeah, you do this, and then you turn, you face west, you hark and spit, and by golly, if you don't do that, it ain't going to work. But nobody could tell me why. No one could explain the intricacies. So that led us on this path. Now for the 2.5, or the 2 pounds, and I'm just going to split this in half. It feels like about half, and that's about half. Now, I'm going to get this here all nice and we're just going to let that set for a few minutes. It won't take but just a few minutes for all of that to liquefy. And I did check, where is it? I got it around here somewhere. I did check my pH to make sure that I was in the right range in the very beginning. Okay, so I did, the water here was 5.2, 5.2, 5.2, and 5.2. So I've already done that part. What I will do, though, is right before I pitch yeast, I'll check it again to make sure that I'm in the right range. And if I need to drop it a little bit, I'll add some more citric acid or maybe squeeze a lemon. But be cautious. Don't go too far. You can get down into the 4.8s, 4.7s or so. But your yeast wants that acidic environment. And what that acidic environment does is it prevents any other bacterial growth from starting. Now, once this liquefies, it's probably done now. I just got a few minutes here. What I'll do is I'll transfer it into those two things, and then we're going to get to of course, checking our pH one more time. By the way, if the pH is too low, you can add a little bit of baking soda to bring it back up. It's not that difficult. And is it important? Yeah. Yeah, it's important. All right, and have your hydrometer handy. Now, I got 2 packets of turbo yeast here, okay? And this is our own brand, Barley and Hops Turbo Yeast. When I ran the store, which, by the way, I sold several years ago, I had my own brand of turbo yeast that was mixed up and packaged. And so I've got 24-hour turbo yeast, and I've got 48-hour turbo yeast. Now this is coming from a retailer. What do you think the difference is between 24-hour turbo yeast and 48-hour turbo yeast? One of them says 24-hour turbo yeast and the other says 48-hour turbo yeast. Folks, that's really, I mean, honestly, it's a great marketing tool, but honestly, do you really think that we could develop a yeast that works in only 24 hours and the other one works half as fast? No, what we've got is we've actually got some Distiller's Active Dry Yeast in here with a whole bunch of diammonium phosphate, some yeast nutrients, and some other amino acids and fibers and some things that just make yeast want to go nuts. That's all we got. So, you know, I always say make your own. You know, make your own. This stuff works extremely well. So we're going to add those to one to each one. And when you get a bag like this that says turbo yeast, it says turbo yeast for a reason. This is enough to inoculate or to infect, because you're actually putting yeast in to do something. A good 6-gallon batch. I mean, that's one whole bag. Don't try to save it. There's enough in here for one batch. Same thing here, one batch. Okay. I'm going to do the transfer and I'll be right back. We've got this cooled down to 90 degrees. And yes, these are calibrated at 60 degrees Fahrenheit, so we have to do the correction on it, and that's okay. But right now, that thing, I can see it. And see, I like doing it like this. You can just drop it right in. Because I can look through the glass up this way, and it's a whole lot easier. I'm at 1.090, by the way. But it's a whole lot easier to see it as opposed to looking down on it, where you have to take into consideration what they call the meniscus. You know how that water just kind of goes up and down on the side of your hydrometer, and you got to make sure you're reading it across the bottom. And that's for those finite measurements. You can actually see it from the bottom if you're looking up. It's a very clear line that breaks right at the point of reading. Now, normally we would use, you know, a cylinder, a test cylinder, and you know that's so that you can look at it. You know, you can see it this way. You can look at it like this, but it's like I was describing. You know, when your hydrometer floats, you know, there's that little bit. It's called a meniscus. There's just that little bit of adhesion of the liquid on the stem that goes up and down. It's just a little bit, but for those who are trying to be absolutely precise. And see, at this point now, how precise am I trying to be? I'm looking for a good, hey, I'm going to live dangerous. I'm looking for a good ballpark. You know, my ballpark figure is 1.090, and I'm going to be happy with anything after that. So if I'm at 1.092 or 1.089, I'm not really that worried about it. It's not like I'm labeling this. You follow me? That's, you know, my goal was 1.090, somewhere in that neighborhood. Yeah. So, all right. Now I've tested both of these, and right now we're at the proper temperature. I'm just going to open these up, introduce my turbo yeast, and all I need is my razor. There it is. The introduction of turbo yeast is just so simple. It's sort of like open it up and pour it in. Now, yes, you have the option to make a yeast starter, which would actually be, now think about this, you would take some of this out and put it in another container. Now there are times, like when you're making a mead, making a wine, or there are times when you would remove some of your base and put it in a separate container and heat that up. And then introduce your yeast to get it going, and then reintroduce that. But in this case, I would just take, if I was going to make a yeast starter, I would take, probably about a half a quart, you know, out of that, put it in a jar, add this, and when it started to foam up, I would pour it back in there, and then I would try desperately to rinse that jar out. So my theory is, you know, why, I can skip that step. Why do that when all I really need to do is just pour it in there? It's going to do the same thing. It's just going to prevent. It's going to avoid one step of me putting it in another jar and then taking that jar and pouring it back in there. But remember, there are times when that is beneficial. And again, you're making mead, some wines. There are some really high alcohol beers. A Trappist beer, and I usually mention Trappist, or some of the monk blends where a yeast starter is really beneficial for, in that case, the wort. This should be a wonderful experiment. Oh gosh. And then all we got to do is just give that a stir. And you'll see that those yeasts are going to go bat crazy. Yeah, you know me, bat shit crazy here in about probably less than an hour. Oh, but I will also I will also make sure that I'm patient enough to understand that it could take up to 8 to 10 hours for me to get any real kind of action. I know that from experience that a turbo yeast is pretty quick in getting active. Now, why am I not adding any other nutrients? Because remember, this is a sugar wash, and a sugar wash has nothing else in it but water and sugar and yeast. Well, if I was just going to add daddy yeast, the distiller's active dry yeast, well then yes, I would introduce some nutrients because there are none in there. But with turbo yeast, they're already packaged in the turbo yeast pack. Now, when you're using grain or fruits, you have resident in those grains the nutrients necessary for that yeast to populate. All you do is you add 2 tablespoons of yeast nutrient to assist that in order to get that colony moving. You know what I mean? So, and I get a lot of calls about, George, I'm doing this, but nothing's happening. I'm getting no activity in my airlock. And no matter how I describe it, I'm like, you know, they'll say, well, yeah, my hydrometer. Of course, I ask that question. Have you checked it with a hydrometer? Yeah, I checked it with a hydrometer. It's dropped like 50 points, but I got no bubbles in my airlock. I'm like, well, you got a leaky bucket. You got a leaky lid. Because CO2 is going to take the path of least resistance out of that container and not through that airlock. And then, of course, I'll say, oh, no, I checked it. It's all good. Okay. But I got no bubbles. Look, bubbles are not the absolute indicator. If you got a sealed container and your yeast are working, they're going to produce CO2 and you're going to see some bubbles. If you got a small, I don't care, it's like a hair-lined leak around the edge of that bucket, that CO2 is going to escape through that little leak, and it's not going to go up through your airlock, and you're not going to see any bubbles, and you're going to claim that it's not fermenting. But I mean, everything you tell me, oh yeah, and I tasted it, it's starting to get sour. And I mean, every indicator is that it's fermenting, but you're convinced, for some reason, you're convinced it's not fermenting because you don't see bubbles. Just be forewarned, sometimes you won't see bubbles because you have a leak. Now, is there a problem with that? Not necessarily, because if you've got enough headroom in here, just remember that CO2 is heavier than air, okay? And CO2 will lay on top of that and protect your mash or your wash from oxygen. Now, if it's open like this, of course, a breeze of air going through is going to dissipate that CO2. So, but if you got a lid on here and it's just like around the edge of it's leaking, you're not going to dissipate that, and you'll always have that level of, or that layer of CO2 because it's heavier than oxygen. It'll just sit there, okay? So that's words of wisdom, and that'll help you get through those challenges. When you're looking at it, you're like, you know, for some reason, you know, my hydrometer is telling me it's fermenting, but I don't see no bubbles. So it ain't fermenting. Your hydrometer is telling you it's fermenting. That's science. Your bubbles are sort of like a side note, you know. So believe your hydrometer. All right. Now we're going to try something different today because normally we put an airlock on there, and that's why it brings me up to this. Try something different. I got one of these paint gloves, a rubber glove, okay? And I'll put this glove on top. Let me show you how to do this. I'm going to put this glove, I can see it's starting to, oh yeah, it's starting to build up already. I'm going to put this glove, I just stretched it over the top. And I'll stretch one over top of this one. Now what is this going to do? This is like putting a balloon on top of a gallon bottle. It will inflate, most definitely. There we go. Now, trust me, if you do nothing else from this point on, when that yeast starts to get really, really active, yep, it'll do that. It'll blow them off. Well, that's not what happened. That one just fell off. What will happen is that these fingers will start to extend, you know, and they'll get full. And if you don't do anything else, it'll blow off. It'll take off on you. Now, you can put cellophane, saran wrap with a rubber band around it, and that'll do the same thing. You know, you'll see this big bulge in the center, but if you leave it like that, it's going to blow it off. So what you do is you just take a real small, I got one of these little tiny dental tools, you know. You know what I'm talking about, the ones they use to scrape your teeth with. Yeah. And what I'll do is I'll take, once it starts to blow up, because I like to see this when it's starting to inflate. And once it gets inflated, I'll just, it's like the middle finger, I'll go to the middle finger and I'll put a little hole in it. And that allows the CO2 to escape out of that little hole, but it'll also leave that finger stuck. Maybe I'll use one of the other fingers. Yeah, but I'll use the thumb. It'll leave that finger stuck up and it'll be blowing out. But again, I'll have CO2 that's on top of here, that level, and I'll just let that ferment. And that's well enough for it. It'll just keep going. Okay, what are your questions? It's as simple as that, folks. It's sugar, water, yeast. Once I put it together, I actually poured, instead of using you can use the spigot, I could have used the spigot, but I actually poured it back and forth once in order to oxygenate my sugar wash. And why do we oxygenate it? Because oxygen is necessary for the anaerobic phase. Yeah, the anaerobic, or is it aerobic? No, it's aerobic. Yeah, the aerobic phase of yeast development, and then the anaerobic phase after that. So the yeast is your friend in the very beginning. Once it develops, it's taking care of all that oxygen. You don't want any oxygen in there. It'll take off. It'll do its thing. Simple as that. Until next time. And you know, now we've got 2 mashes, so guess what's coming up? Yes, we're going to run this, and we're going to make some fine, delectable, maybe we'll make a limoncello. Oh, maybe we'll just make a nice gin. Oh, that would be nice. I think I'll make some more of that, that gin I made a couple of months ago. We've run out already. The wife loved it. So, in any event, we'll have plenty to do. Happy distilling. Just wanted to show you. An hour later, this has been an hour, and oh yeah, you can see that this one's really getting at it, and this one's a little bit slower to come along, but it's going to make it.